Okay. Oh, wait. Okay, there's the web work. So the only problem-solving request that I had for today was from this most recent homework, section 2.4 on exact equations, and problem 2 in that section. So I went ahead and copied down the problem over here to start. I'm going to bring it up to the front. And we're just going to go through this kind of start to finish. So the first thing the WebWorks asking for is this m sub y minus n sub x. Remember that when we have an equation in differential form, we want to check whether dm dy is equal to dn dx. That's going to be the same as m sub y equal n sub x using the notation they have here, or you just subtract the n sub x from both sides, that m sub y minus n sub x is equal to 0. So that's that same condition that I told you all to start these problems with, just sort of represented a different way for the WebWorks solution. So to do this, I have to identify my m's and n's and then take a bunch of partial derivatives. So m is the thing that multiplies dx. That's 4xy squared e to minus x minus 4e to minus, minus x sine of x plus 2e to minus 3y. And I'm going to have to take a partial derivative of that with respect to y. So from this first term, I'm going to get, actually let me indent it a little so it's easier to read. From this first term, I'm going to get 8xy e to minus x minus 0 from the middle term because there are no y's there, plus 2e to minus 3y. Oops. It's a y, not an x. So it's 2 times minus 3 is minus 6 e to minus 3y. So we're going to get 8xy e to minus x minus 6 e to minus 3y. My n is the thing that multiplies the dy in the equation in differential form. So it's that 4x squared y e to minus x minus 6e to minus 3y. And I need to take the partial derivative of that with respect to x. So from this first term, I'm going to get 8xy e to minus x, taking a derivative of this 4x squared, plus minus 4x squared y e to minus x. That's from taking a derivative of that e to minus x. So I'm just doing a product rule here. And then minus 0, because the second term only depends on y. So then I would get altogether 8xy e to minus x minus 4x squared y e to minus x. So then this quantity I was asked for, m sub y minus n sub x, is going to be 8xy e to minus x minus 6e to minus 3y minus 8xy e to minus x plus 4x squared y e to minus x. Because I'm subtracting this negative term, so that turns into a positive. Sometimes I see you all forget to distribute those subtractions, so just watch your signs here. And when I simplify that, I'm going to get that those 8x terms cancel out. So I'm just going to be left with 4x squared y e to minus x minus 6e to minus 3y. So let's go ahead and type that in. 4x squared y e to minus x minus 6e to minus 3y. Let's check that before we continue. Yep, we got that. And so we're going to be using this to make an integrating factor that turns this equation that, because these two things aren't equal, this equation isn't exact. But if we multiply by an integrating factor, then we can make it exact. And so that factor, we're told, is going to be calculated m sub y minus n sub x over n. So I just found m sub y minus n sub x is 4x squared y e to minus x minus 6 e to minus 3y. And then I knew n right here to be 4x squared y e to minus x minus 6 e to minus 3y. But that's the same in the numerator and the denominator. So it's actually going to be 1 when those two things cancel each other out, which is correct. And 1 is a constant that you can think of as a function of a variable. That function just never changes. And so the function of x only that we needed to get in order to make an integrating factor is actually going to be one. And I'm not sure if the notation from you is supposed to be the e to the integral 1, but let's go ahead and check that real quick. No. Okay. Sorry. So I guess I'm going to call that I. I can't remember what I did in your notes. But in order to get your integrating factor, you integrate whatever you got there and then put it to an exponential. So it's e to integral 1 with respect to x, or e to x. Which is what WebWork wanted in that step. See how it's sometimes kind of like a guess what they were asking for kind of thing. Anyhow, the way we use the integrating factor is we multiply both sides by this thing that only depends on x, or alternatively, if you kind of swapped the order of everything here, it could be a thing that only depends on y. And then the resulting equation should be exact. So let's go ahead and do that next. I'm going to go ahead and copy paste our equation onto the next slide. Copy. Paste. And what I'm going to do is multiply both sides by e to x. So 0 times e to x is just going to be 0, so that side stays unchanged. And I'm going to move this e to x inside all of my parentheses without showing it. So if you need to like pause and kind of catch up with what I'm doing, let me, don't let me stop you from pausing the video. But, so I'm going to get 4xy squared e to x times e to minus x is just 1. Minus 4 e to minus x times e to x is again 1 sine of x. Plus 2 e to minus 3y e to x dx. Plus 4x squared e to minus x times e to x cancels out. Oops, forgot that y. Minus 6e to minus 3y e to x dy. So in this case, my m is going to be 4xy squared minus 4 sine of x plus 2e to minus 3y e to x. And my n is going to be 4x squared y minus 6e to minus 3y e to x. And then we're just supposed to type those in these boxes. So 4x squared, oops, sorry, the first one is 4x y squared minus 4 sine of x plus 2e to minus 3y e to x. And 4x squared y minus 6e2 minus 3y e to x. Let's see if that went in all right. And it did. I didn't make any typos, so that's great. And now we have a new equation that we can check if it's exact. So we're going to have dm dx is equal to, dm dy is equal to 8xy minus 0, because there's no y in that second term still, minus 6 e to minus 3y e to x. So 8xy minus 6e to minus 3y e to x. And then dn dx is going to be 8xy minus 6e to minus 3y isn't changed by derivatives in x, and derivative of e to x is just e to x, so we're going to get just e to x there. And now we can see that these are the same thing, and let's make sure it's the correct same thing. 8xy minus 6e to minus 3y e to x